So in the previous class, we were discussing about, about AC currents. Okay. So it's like a oscillator. Means when I speak about AC currents here, I'm not speaking about the wall outlet, the current which is coming out from the wall outlet. It is it's like the output of a frequency generator or output of an oscillator. Output of an oscillator. So which is very, very important for almost all the electronic devices, because all the electronic devices are fixed with it comes with a timer. The timer has a oscillator. That oscillator has a certain frequency and time period. Based on that, the speed of the device runs, or the speed of the computer or the device depends upon the oscillator. Now, the first one was what? There are three components: resistor, capacitor, and inductor. Okay, these are the three components: resistor, capacitor, and inductor. What is the function of resistor? What is the function of resistor?
To resist the flow of current.
To resist the flow of current. Okay. And what is the second? One more function of resistor. One more function of the resistor.
Flow of charges. To resist
No,
the
no.
flow of charges.
One is it opposes the flow of current, not resists the flow of current. Second one is it drives the voltage towards itself. It drives the voltage, potential difference across the component. Second is what is the
Yes.
function of a capacitor? What is the function of a capacitor? Capacitor means it stores
It stores
it stores electrical energy in the form of electric field. Okay, capacitor stores electrical energy in the form of electric field. And the second purpose of capacitor is it is used for filtering purpose. Okay, it is used for filtering. Okay, so these are the two functions of capacitor. Filter means what? Filtering means it blocks DC and allows AC to pass through it. So next is inductor. What is inductor? Inductor means it stores magnetic energy in the form of magnetic field. Inductor is a component which is used to store magnetic energy in the form of magnetic field. These are the, but second function of inductor is what? It's the same purpose. It is also used for filtering to block DC and allow AC to pass through it. So these are the three components. Now coming to these are the three components. Now when we started with like phase, what is phase? Can anyone say what is phase? Just do one thing. Do a quick. Yes, what is phase? What is phase? Can anyone say?
So it is the
Yes, what is phase? Phase means, see, phase means it is the angle made with its initial position. Angle made with its initial position is said to be phase, or it describes the motion and direction of a particle. It describes the motion and direction of the particle. These are the two definitions of phase. Now that means what is a phasor diagram then? What is a phasor diagram? This we did in the previous class. What is a phasor diagram? Representation of a wave on a circle. Representation of a wave on a circle is said to be a phase. Okay. Sorry, phasor diagram. So once again, one second. Now, so now here we have first what is phase? Phase is angle made. Phase is angle made with its initial position. Okay, angle made with its initial position is said to be phase, or which describes the state of motion and direction of the particle. Okay, it describes the state of motion and direction of a particle, that is said to be phase. Then what is a phasor diagram? Phasor diagram means it is, what is phasor diagram? Phasor diagram means it represents a wave on a circle. Okay, representation of a wave on a circle is said to be a phasor diagram. Now we have in phase, out of phase, and constant phase difference. Can you tell me about that? Can you tell me about in phase, out of phase, and constant phase difference? Anyone? What is in phase, what is out of phase, and what is constant phase difference? Yes. Anyone?
In phase is when the phase angle is 0.
Is the phase angle
And-
what happens? Okay, just wait 1 second.
Resistor.
Once again, phase means phase means angle made with its initial position, or that is, it describes the state of motion and direction of a particle. It describes the state of motion and direction of a particle, which is phase. And phasor diagram is representation of a wave on a circle is phasor diagram. Representation of a wave on a circle is phasor diagram. Now we have in phase, out of phase, and constant phase difference. What is in phase? If the angle between the two waves is 0 degrees, that is in phase. And if the angle between the two waves is 180 degrees, then that is out of phase. So for in phase, I have given an example, that is soldiers marching like on a Republic Day parade. Okay, that is in phase. Out of phase means like 180 degrees. And constant phase difference means leading or lagging of a wave. One is leading and the other is lagging. That is constant phase difference. Now, next one, we have a resistor in AC. So when we connect resistor in AC, what will happen? We are applying the Kirchhoff second law. What is Kirchhoff first line second law? Kirchhoff first law says that current coming to the junction equal to current leaving the junction. And what is Kirchhoff voltage law or the loop law? Means the potential difference, the sum of the potential difference in a closed loop is 0. The sum of the potential difference in a closed loop is 0. That is said to be the second rule, Kirchhoff second rule. So we are going to apply the Kirchhoff second rule here. So in resistor, when we applied, both both current and voltage are in phase, means 0 degrees. There is no phase angle between the voltage and current. So that happened in where? In resistor circuit. Now that happened in resistor circuit. Okay. So now after that, so angle is 0 degrees. So now we have the second one, that is AC voltage applied across an inductor. Okay, AC voltage applied to an inductor. So what happens? This is the inductor and this is the E. Okay, so now we have V is equal to what? V is equal to Vm sin omega t, and we have V minus L into di by dt equal to 0. Why? Because the voltage across the inductor is written as L into di by dt. Voltage across inductor is L into di by dt. So V minus L into di by dt equal to 0. Then we bring this on the other side. Minus will become plus. Then cross multiplied. Di by dt is equal to V by L. So what do we write now? V is equal to what? Vm sin omega t. So di by dt is equal to what? V by L into sin omega t. So now what we are going to do? We are going to integrate it now. See, integrate with respect to what? Like when we say differentiation with respect to x or differentiating with respect to t. Same way. We have in integration also, we have integrating with respect to x or integrating with respect to t. So integration of di by dt into dt equal to what? Vm into L integration of sin omega t. So I is equal to what? I is equal to Vm by L into minus cos omega t by omega plus c. Now, so now here what happens here? I is equal to minus Vm by omega L into cos omega t plus c. Now, minus cos omega t is equal to what? Sin omega t minus pi by 2. Now, so what happens here? I want to convert. See, because I started with sine, I want to end with sine again. Because comparison only can take place if they are in the same function. You cannot compare sine function with the cos function. You cannot compare sine function with the cos function. See, once again, the input voltage is given by V is equal to Vm sin omega t. What is Vm? Vm is the maximum voltage. In some books, it is written as V0. V0 sin omega t. Now, the voltage across this and the voltage across this should be equal to sum should be equal to 0. So voltage V minus L into di by dt is equal to 0. Bring this on the other side, minus will become plus. Then cross multiply, you will get this one. Then what you're going to do now? What is V? V is equal to Vm sin omega t divided by U. Now Vm by L, write it separately, then sin omega t. Then what you're going to do? You are going to integrate it. So when you integrate integration of di by dt into dt equal to Vm by L into sin omega t. Now here what happens? When you integrate di, then it becomes I. That means integration is of full value. Vm by L, sin omega t integration is minus cos omega t. Omega t derivation is what? So omega t derivation is what? Omega. Okay, plus c. Is that clear? So why? Because sin x integration is minus cos x. Sin x integration is minus cos x. Please note down this somewhere. If bio students, please note down sin x integration is what? So sin x integration is what? Minus cos x. Okay. And cos x integration is what? cos x integration is sin x.
Sin x.
Okay? So this is the value. So अब क्या हुआ? What we have done is we got, when we integrate it, sin omega t will become minus cos omega t. Derivation of omega t will become omega. Derivation of omega t is omega. Now write it separately, minus Vm by omega L into cos omega t plus c. अब क्या करना है? Because this is my starting point. This is my starting point. I started from here, but I got cos. I cannot compare like that, sin with cos, because sin का wave अलग है. माने sin is going like this. Cos is going in the other way, right? Cos is going in the. How can you compare this one with this one? You cannot compare. So for that reason, we are converting cos to sin. How do you convert? That is, sin 90 minus theta will become cos theta. Understood? Sin 90 minus theta will become cos theta. Is that clear? So we did sin 90 minus theta is cos theta. We did like that. Then we substituted in the place of cos. Okay. So what is this whole thing? This whole thing is what I am. Okay. Vm by omega L is Im. Now, so it will become what? Im is equal to Vm by omega L. So where omega L is what? Inductive reactance. So we can write here what? XL is equal to omega L. And it is measured in ohms. Is that clear? So we can write Im is equal to Vm by XL, where XL is directly proportional. Did you understand this one? See what we wrote here? I is equal to Im sin omega t minus pi by 2. Im is equal to what? Vm by omega L. Now, what is omega L? Omega L is XL. XL is equal to omega L. So what can we write now? Im is equal to Vm by XL. So what is XL? XL is directly proportional to L or directly proportional to nu. What is the meaning of that? As the inductance value increases, reactance also increases. Why did they give the name reactance? See, suppose resistance means opposite of flow of current. Reactance means, like suppose there is inductor with you. Suppose there is an inductor with you. When you are supplying the current, in the beginning the inductor will oppose the flow of current. It will not easily allow. It will not easily allow, right? So is that clear? So that is why that in the beginning it is opposing, right? That is known as reactance. Simple way I told, like suppose the room is completely dark and suddenly light comes up, then you will close your eyes for a moment, is it not? Because you don't want that much light to enter, because our cornea, what is it? Pupil is completely open, fully open. So that much of light cannot bear, our eye cannot bear that much of light. So it will close for a moment. Then slowly it will open. That is meant the reactance. Is that clear? So inductor is also offering some resistance. That resistance is known as inductive reactance. Is that clear? Now, so reactance is also having the same units of resistance again. Reactance and resistance are having the same units. What is that? Omega. That is omega or ohms. Now what happened now? XL. So XL is directly proportional to L and XL is proportional to nu. What is the meaning of that? Jitna inductor value badega, utna reactance bhi badega. The more the inductor value, the more will be the inductive reactance. The more the frequency, more will be the inductive reactance. So they plot a graph here. See, when they plotted a graph like this, the graph was like this. So XL, what is this? This is XL. Okay. XL is what? Inductive reactance. Then we can write frequency also here. Is that clear? As the frequency increases, inductive reactance also increases. This graph is not there, but in the examination, they're asking this graph. This graph is not there in the textbook. This graph is not there in the book, but they're asking big questions based on this graph. Okay, so this is new frequency. I will adjust the camera a bit. The frequency versus XL. Okay, please note down this. Any doubt in this one? Any doubt? No one is saying yes or no.
Clear, sir.